Hi there, this is just a short video showing our little laboratory for the testing of our water controller software, stability, radio communication between different units. So this is a 5-liter little digester, double walled, that will allow us to heat it. The external wall or the water jacket on the outside is so that we can circulate hot water and heat the digester to whatever temperature we require. It's completely mixed, automated loading, pH control through the automated loading, and whatever gas is taken off we'll put into sample bags and then have it analyzed to see the composition of the gas. So the way it works, I have a buffer tank over here. It's all gravity fed, makes it more energy efficient. The buffer tank over here is fitted with a little agitator motor up at the top. You can see the mixing shaft over there and the impeller. That's just to prevent everything from stratifying, because there's about a 3-day retention time within this tank. So I just keep it full, and then the controller takes over the loading of the digester and make sure that there's a constant load into the digester. I'll just switch on the agitator so you can see the operation. I've made sure that there's a manual operation for everything, so I don't have to rely on just the controller in an automated stage to run the whole plant, so that I can manually load and mix the digester. The way the loading occurs is through the pneumatic valves over here. It's a very fast acting pneumatic valve which allows me small amounts of feedstock to go into the digester at any one time. This is just a stop valve for maintenance and so on. You can see on the inside here, I'll activate the valve. You can see how quick the action is. That's very quick, which allows on small amounts. So all it is then just the time delay on how long the valve is opened and closed. That will dictate how much sludge is fed into the digester. The feeding goes into the bottom of the digester and it's expelled up at the top. The top goes to another pneumatic valve that sits at the bottom here, that is also operated through compressed air. As you can see, this is a bit slow because my compressed air is running out. I'm not running the compressor at the moment. So it's basically just to make sure that the digester is kept at a constant level all the time. I've also then fitted another pipe at the back here that allows me to drain the digester from the bottom if I need to start a whole new process, drain out everything that's inside the digester. At the top you can see a mixer motor which is attached to an impeller on the inside there. That allows for quite vigorous mixing. I'll switch it on, you can see. And the vigorous mixing is necessary when you want a homogeneous feedstock or homogeneous digestate inside the digester. You can just see on the water surface there, it's quite a bit of movement, and every now and then there's a little vortex that's formed as the water is stirred. At the moment it's just filled with water because I'm busy still testing to see if there are any leakages. In the back you can see there's a pH probe. At the moment it's still with its cover on because I'm still setting up. And at the top here we have another entry point for instruments, which will be the temperature probe, just so that we can find out what the inside temperature of the digester is and try to maintain it through the heating of the water jacket, it's a double wall digester here. So on the outside there's a water jacket that's filled with hot water, also controlled through the controller. Over here we have the gas takeoff, so whatever gas is produced we'll take it off from here, put it in sampling bags and then have it analyzed by a third party. The hot water is sourced from this tank over here. I've installed a geyser element and a thermostat on the geyser element. At the moment, I'm not sure if it's really clear, the temperature is just below 50, which I find is more than enough to maintain a mesophilic 35 degrees Celsius inside this digester. So the way it works is, this is the little circulation pump. The water is extracted from the bottom, from the tank over there, pumped into the bottom of the water jacket, filled up from the bottom, and then it comes out the back. It's a pipe that goes around the back of the digester. I'll move it over there, and it's circulated. So this is a closed loop. I'll switch it on. It's a very quiet little pump. I'll bring the camera closer so I can. You can't really see much movement in the water. I should actually add a colorant or something like that. Okay, then over here is our piglet or remote terminal unit. This gives us the interaction with these 8 digital outputs on this side here. That is the power supply, and then we have 8 analog inputs on this side here. So this is all the instruments, and this will switch on the valves, the mixers, and the pump, and so on. All the instruments that will go in here is temperature probes, pH, and unfortunately for this small digester it's very costly to buy anything to measure the gas volume. But we will also measure the temperature inside here, because part of the software will be if the temperature within the heat source goes below what we require the digester to be, the heating process will be stopped completely so that we don't cool down the digester. You can see in the back here, here's the cable for the pH probe, and all the cables are attached to a cable tray there, and it goes to the bottom where a row of connectors are situated, where all the instruments and at the moment all the valves and the pumps are connected. The instruments will go over there, and this is all the digital outputs. It's quite complex at the moment because we've got 220 volt AC equipment, 12 volt equipment, as well as 24 volt equipment. So it's quite complex. The 24 volt will be mostly for the instruments. The 12 volt is for the agitators, the mixers, and the little heat pump. The 220 volt is for geyser element, and basically also to power up the DC power supplies. All of this is connected to an inverter system that operates as a UPS. So if the national grid goes down, I have continuous operation over here. The only thing that won't operate is the heat source for the heating of the digester, because the element within the let's call it a hot water, it's not really a boiler because I'm not boiling the water, but the element is requires a capacity greater than that of my little inverter. Okay, so as I said, the main controller will be based off-site, purely so that we can test the radio comms. So the radio comms is through this antenna with the main controller, so that we can test the stability of the radio comms, as well as the stability of our software, our firmware, to run a digester continuously 24 hours a day based on inputs.